So on Monday we talked about transition metals and how they can have different charges. So today we are going to really focus in on how to figure out what charge a transition metal is representing within a compound. And we are going to use kind of that reverse crisscross method quite a bit to help us figure it out. So if you read with me in our box here, it says elements in the D block can exist with several different charges. To determine which charge a transitional metal is presenting in an ionic compound, observe its anion partner. There are two ways to find the mystery charge of these metals. So we have mathematically and the pattern way. So I'm going to actually start with the pattern and then we'll talk about mathematically. Pattern, this is kind of the easier, less thought process method. But it doesn't always work, so that's why I also have mathematically included here. If you do the reverse crisscross method, then you will, if you remember, you take the charge and you make it the how many. If you kind of do that backwards, take the how many and reverse crisscross it to become the charge again of the partner. So a couple of things, these are the times where it kind of breaks down, so things you have to remember. Polyatomic ions are their own unit, so the subscripts are part of that polyatomic ion and do not participate in the crisscross method. So you got to pay attention to parentheses, and you never want to crisscross the subscripts of polyatomic ions. And secondly, check that the charge of the anion agrees with the periodic table or the polyatomic ion list. If it does not, then you have to unreduce the chemical formula as well. So if you remember, doing the crisscross method, sometimes we have to reduce out a number. But if we do the reverse crisscross and get the charge, now it doesn't represent it correctly. So you'll have to take that extra step. So there's our pattern method. Mathematically, what's happening is that ionic compounds are neutral, so the total positive charge, or the electrons given, has to equal the total negative charge, or electrons taken. So I have an example here. Mn3N2. If you look this up on the periodic table, you'll notice Mn is in the D block, so it does not have a set charge for us to find based on the pattern. But we do know that nitrogen has 5 valence electrons, so its charge will be -3, always. So if you read our italics here of an explanation, it says nitrogen atoms always follow the octet rule by taking 3 electrons, so -3 from their partner. Since this compound has 2 nitrogen atoms, 6 total electrons will be taken, -6, from its partner, the manganese atom. Put another way, 6 total electrons must be given by manganese. So if you think about this like the puzzle pieces, we've got 2 nitrogens. That's a total of 6 kind of puzzle piece teeth. That means the manganese each have to give the same amount in order to be the same total, 6 and 6. There are 3 manganese atoms in this compound, so each manganese will give 2 electrons, and as a result, each manganese ion has a +2 charge. Or like we said, you can reverse crisscross. This 3 becomes the charge of the nitrogen, and this 2 becomes the charge of the cation. Okay, so there's your reverse crisscross, or kind of the mathematical what's happening explanation for the transfer of electrons. So we have a few different levels here of determining the transition metal charges. So level 1 is when we can do a real basic crisscross reverse, and it will work perfectly, no need to unreduce, there's no polyatomic ions, just straightforward elements. Remember that anytime there's no subscript written, it's an implied 1. So I'm going to go ahead and write those on all of these that don't have a subscript. Okay, and then we'll do our reverse crisscross. So our 2 becomes the charge on the cation, and the 1 becomes the charge on the chlorine. Just reverse crisscrossing this. I'm going to go ahead and write all of our ions before we name. Iron. We're getting the 3, reverse crisscross, 2, same thing here, reverse crisscross, all of your charges, okay, so again, if you are feeling a little lost, remember, take your subscripts and pull them back to charge. So this will become, the 2 is going to become the cation charge, and the 1 is going to become the anion charge. Okay? And you know positive and negative because cations are always positive and anions are always negative. We'll do that for every single one of these. These are all considered level 1 because if you check the anion charge, they are all in agreement with the periodic table for that ion. Chlorine, bromine, and fluorine are all halogens with a -1 charge, so those are all good. And then we have nitrogen, -3, oxygen, -2. They all match what should be their charges. Now we can name them using their charges. So Zr is zirconium. Then we put in parentheses II to show it's a 2 charge. There's our cation, done. And then chloride. Fe is iron. And then it's a +3, so we'll put Roman numeral 3. Oxide. I'll let you finish these off. Level 2, this is where we're going to use polyatomic ions, but you can still do Criss-Cross method. So wherever there's no number, let's write the implied 1, so it makes our Criss-Cross a little easier. Okay, so the reason this is level 2 is because now we have to pay attention to parentheses for which number is crisscrossing. In this case, it would be our 2 and our 1. Do not touch this 3 on the nitrate. It's always part of the nitrate. So when you crisscross these, +2, -1. It's the exact same process as level 1, but just paying attention now to parentheses. And do not touch subscripts that are part of the polyatomic ion inside of that parentheses. So this is CO +2, NO3 -1. And look at that, this is in agreement with the list. This is nitrate, so we can easily write this name, cobalt 2 nitrate. Continuing our crisscross, reverse, cation charge, anion charge. Do not touch the little 4 inside the parentheses. That is not part of the crisscross. It's part of the polyatomic ion. Manganese 2. Remember, charge is Roman numeral. It's not the how many. That's one of the common things I see with students. They'll look at the chemical formula and they'll say, oh, this is manganese 3 because there's 3 of them. Nope. It's not telling how many, it's telling the charge. So always do your reverse crisscross before you write the Roman numerals. This one, same thing. +4, -1. Titanium, 4, hydroxide. Okay, I'll let you finish the other 2. Level 3 and 4 are where we start to have that kind of reducing challenge. So you'll notice all of these are a 1-to-1 ratio. And again, look, this is a polyatomic ion, so it does not have parentheses, but if it did, that 4 belongs to sulfate. It does not participate in the reverse crisscross. This one doesn't have parentheses to show you, which is why it's the next level up of challenge, because you really have to acknowledge that the polyatomic ion owns the 4s and the 3s in these particular listings. Okay, so you'll notice all of these have 1 as their count. So when you do the reverse crisscross method, you'll end up getting +1, -1. However, we know that's not true of the charges of these anions. So sulfate, SO4, you'll also have to acknowledge and notice that sulfate always has a -2 charge. That has to be. So when you do this crisscross and you write them down, just like we did in level 1 and level 2, you're going to notice that this is not correct for sulfate, right? Because it has to be this guy. So what happened was, this is an example of one that was reduced. So let's unreduce it. To get sulfate back to -2, we just need to double our charges here. +2 and -2. Now we are set with the correct charge. So level 3, we have to unreduce it and pay attention to our polyatomic ions. Again, if we flip these, you're going to get +1 and -1. However, we know that sulfur on the periodic table always has a -2 charge, and it does not agree here. So again, unreduce by multiplying them both by 2, and now we have the correct charges. I'll let you finish these 3. And level 4. Alright, so now we've got reducing and polyatomic ions all at play here. And it's more than just a 1-to-1 ratio. So level 3 is a 1-to-1 ratio for everything, which means all of our cations and anions will be a 1-to-1 ratio in their charge as well. Now level 4, we have another level because they're different charges. So same process as level 3, thinking about charges when we do the crisscross. So for this first one, I'm going to do the crisscross reverse, and I get +3 and -1. So if I were to just write this down as if it was kind of a level 1, and I get this. But I should be hearing red flag or seeing red flags and hearing bells go off telling me, hey, we've got a problem because sulfate has to have a -2 charge. So in order for this to be -2, I need to double everything in their charges, unreduce it. So this will be SO4 and B +6, because we know sulfate has to be a -2 charge, not -1. So we doubled the charge. Okay, next, same process. We notice red flags because O always has to be -2. So again, what do? To get O to be -2, we need to double all of our charges. Unreduce it. So let's do the names on these two. Vanadium, our charge is 6. I wrote 4. Vi, and sulfate. And Sn +4 is 10. 4. Anion is oxygen, but we changed the ending. Oxide. I'll let you finish these 3. And that's all for our transition metals.